Hey guys, welcome back to my YouTube channel. In this video, we are going to solve the insertion of two linked lists. This is a continued playlist or continued video of our linked list playlist. So if I'm jumping directly to this problem, I will say watch the video from the very beginning because I'm covering all this topic in the sequential form where you can build your logic from the beginning. So today's problem is the insertion of two linked lists. Is again a lead code problem. The problem number is 160. So what this problem is saying, they have written a lot of text or description, but I'm not gonna read all those things, but I will describe them briefly. So you have given the two linked lists or the head of the two linked lists. First one is this one, first one, the second one is B. So you have given the head of the two linked lists and you have to find their insertion point, means where they are meeting. For the linked list 1, the nodes are the A1, A2, C1, C2, C3, and the linked list for linked list B, the nodes are the B1, B2, B3, C1. So you can see that C1 is the insertion in, or you can say inserting point between the two linked lists. So you have to return this node C1. If you see example 1, in that there's a first linked list 41845. The second linked list is 561845. Shows the intersection point of the two linked lists are 8 in the example 1. For the example 2, it will be 2 because it's the common the intersecting point of the two linked lists. And for the example 3, they are not intersecting each other. So there's nothing, I mean, so in that case you have to return the null. So how you got the problem statement, but now how will you solve it? I will give you a trick to solve this problem. A trick will be just put the pointer here on the linked list 1 on a head A and another pointer on the linked list 2 on the head B. So what you can do, go traverse, move your head 1, keep moving it until it reaches null, and the same for the head 2, keep moving it until it reaches the null. After that, when my head 1, head A reaches the null, you can say it, head A, can you move back to the head of the other linked list? And again start traversing it. And same for the head B, when it reaches the null, can you see, can you move to the head of the another linked list? Start traversing again. What will happen? So let me explain it into detail. So you have given the two linked lists. One is this one and one is a A1 to C3. Okay. So what I will do, I'll move my temp one by one in each linked list, and at the same time move temp 2 one by one into their path. And there was a twist. When my temp 1 reaches the null, I will say temp 1, the path of temp 1 is this one. So when my temp 1 reaches the null, I will say temp 1, can you move to the head of the other linked list? So what will happen? And thus I will do the same thing for the temp 2. When it reaches the null, I will say, can you move to the head of the other linked list? What will happen? Let me explain you. Suppose my temp 1 is at the head of the first linked list and temp 2 is the head of on the second linked list. So my temp 1 and temp 2 both are at the head of the linked list. So my temps 1 move here, temp 2 move here, temp 1 move here, temp 2 moves to here, temp 1 moves to here, temp 2 moves to here, temp 1 moves to here, and temp 2 moves to here. When my temp 1 moves to the null, what will happen? It will say go point to the head of the other linked list. So my temp1 moves to the B1 and my temp2 moves to the C3. When my temp2 moves to the null, I will say go to the A1. So what will happen? When my temp2 reaches here, my temp1 reaches here, my temp1 reaches the B3, my temp2 reaches to the B1, B2, A2, sorry, and my temp2 reaches here and my temp1 reaches here. So yeah, they are meeting at the same node. So if they are meeting at the same node, you can directly just return this node, whether it's temp1 or temp2 is up to you because they are pointing to the same node. But how is possible that they are meeting? There's a mathematical expression too. Suppose this is the A length and length of A, and suppose this is of length B, and the common area is of length C. So my temps ones A node plus C node. Then again I'm assigning them to B1. So it's move B node. Okay. So my temps one A plus C plus B. Okay. And the same and my temps to move B plus C nodes, and then I'm assign it to A. So it's A node. A node. So basically they are traveling the same amount of distance. A plus B plus C. A plus B plus C. So I hope you got the trick. So let's try to run it up and let's see whether it's running or not. So I have opened up my LeetCode. So what we need two pointers. Okay, one is temp1 or another is temp2. So I will create temp1. It will pointing to the head of the first linked list. So it will be head A, and the same for the linked list temp2. Temp2 it will be pointing to the head B. Let's rename it to temp1. And what we need to do until until my temp1 not equal to temp2, I will keep going on. This is what our base condition will. So we will keep going on and keep comparing the value. In the while loop, what we need to do, we have to move our temp one by one. So I will move my temp one to its next, and at the same time I will move my temp two to its next. Okay, and when if my temp one equal temp two means they are meeting in the same node, and you can directly return temp one or temp two is up to you. Let's suppose I'm returning temp one. If and if what if they reaches to the null? So if my temp one reaches to the null temp one, I can simply say temp one, can you point to the head B? Go point to the head of another linked list, other linked list, and the same for the B or temp two. If what if my temp two reaches to the null? So I will say temp two, go point to the head of the other linked list, means head of A. And after the while loop, you can simply return null or temp A or B, whatever, because they both will be pointing to the null. So let's run it. It will be working. I don't know why it's showing a negative time here, minus 1 minute and minus 50 seconds. This should be working. And let's move to the Java solution. By the way, I think you can do the Java solution by yourself because from the first video I have been teaching you the same thing over and over. So I think you can do it by yourself. Anything else we need to change? Tell me what I need to change. And I don't think I need anything to change. Okay, so I hope you like my video or like this approach or trick. So if you like, do like, comment,